Hey guys, so in this video we are going to see how we use variables in Unity visual scripting. So let's start. First of all, let's just remember what is a variable. So basically a variable is a place in memory where we can store a value. And we use variables when we need to store values that we need to access and change during the game execution. So for example, let's go back to our game and see some examples of variables that we are using. In the game, we have three main variables that we are using. So we are using a variable to store the ammo, the score, and the time of the game. So all these are values that we need to set at the beginning of the game. So we set the ammo to 100, we set the score to 0, and we set the time to 60. And then throughout the game execution, we are accessing this place in memory. So for example, let's consider the ammo variable. When we start the game, we have this space in memory where we store the number 100. Then throughout the game, every time the players press the mouse button, we change the value in that space in memory by -1. So we change it to 99, 98, and so forth. So basically, this is why we use variables. So it's a place where we can store a value. And when I say a value, it means that this value can be a number, it can be a text, it can be a Boolean value, like a true or false value. And then throughout the program or the game execution, I can access that place in memory and say, okay, what's the value that's inside that place in memory? And do something according to the value, or even change the value that I'm storing in that place. So this is a variable. And in Scratch, using variables, we have these blocks that allow us to use variables. So we have blocks to set a variable number and blocks to change a variable number. And we are going to see how we can do this in Unity. So to do this and to start working with variables, first of all, we are going to create a game manager in Unity. And a game manager is usually a common entity in most games. We use a game manager to basically deal with the overall logic of the game. So in this case, in this game, the game manager is the one responsible for basically dealing with changing the ammo, so detecting when the player presses the mouse button, changing the ammo, and see if we are out of ammo, we end the game. Also, it is also responsible for dealing with the time of the game. So basically, the game manager that decreases the time and see when the time ends is also in the game. So you can see that the game manager is basically the one responsible for the overall logic, for the win and lose condition of the game is the game manager that does that. And in Scratch, to create a game manager is kind of what it's like, kind of strange because in Scratch everything is a sprite, and so we need to create like an empty sprite, so something that we don't see in the actual game, so that we can add some logic to that sprite. In Unity, we don't need to add an actual sprite. We can just add an empty game object. So just a game object to hold the script to have the same logic. In a way, it's similar, but the only difference is that here we have everything is a sprite, while in Unity, everything is a game object. So let's start. Let's go into Unity and start by creating our game manager. Okay, so like I was saying, the first thing that we are going to do is to create an empty game object to hold in this case, not the script, but the graph with all the code for the game manager. To create an empty game object, we come here to the hierarchy view and we select create empty. We are going to call it game manager. And now we can create a new script, visual scripting. So we go to the project tab, we select create visual scripting script graph, and we're going to call it game manager. I don't remember the naming convention that I'm using. Let me see. Oh, yes. I don't know why I'm calling this with lowercase, but this should be uppercase. This is just, sorry, this is just because I'm trying to keep the naming conventions the same as in code. And if you know how to code, and each graph that we are creating is relatable at least in the way that I see it, is relatable to a class or to a script in Unity. And usually classes and a script in Unity start with uppercase. So they follow the camel case, the camel case convention. So I don't know why I was writing the name of the scripts of the graphs in lowercase, but you should write them in uppercase. Okay, so I have the game manager, and then I need to apply this game manager to my the game manager graph to the game manager object. So I add a script machine to my game manager, and I assign the game manager graph. Okay, so now this is our game manager. We have a graph, and we can edit the graph to start implementing the logic. So let's go back now to Scratch and see the logic that we are going to implement. First, we are going to set the variables. Oh, and let's see. I'm going to show you, okay, the comparison once again between the blocks that we use in Scratch and the nodes that we are going to use in Unity. So some of the blocks actually have a direct correspondence. So you can see that we have this if block, and we have an if node. We have a block for the input block for the mouse down, and we have a node for get mouse button down. We have blocks also for setting the variables. For set my variable, we have the set variable, also the block. Now to change the variable, we don't actually have like a block that says, okay, change the variable by 1. So basically in Unity, what we need to do is if we want to change the variable value, what we need to do, let's say, for example, I want to change the value of a variable by 1. What we need to do in Unity is we need to, okay, give me the value of that variable. So we use the block get variable, give me that value, then we perform the operation, in this case, subtract or add a certain number, and then we set the value again. But we'll see this in just a bit. This is just to give you an overall view of the blocks that we are going to use in this video, comparing to the blocks that we used in Scratch. And this wait for seconds and this time we'll see in just a bit. So now let's go back here and say, okay, here we start by defining the variables. And to define variables in Scratch, we have the variable section. We make a new variable, and then we have the variable available here, and we can set the values at the beginning of the game. Once again, we need to do this every time we start the game. We need to use the block to actually set the value, so that we are resetting the value when the game starts. Remember that when we play games in Scratch, all the changes that we make in the game actually persist. So we always need to reset the game, reset everything from at the start of the game. In Unity, it's a little bit different. So let's see how we create variables in Unity. So in the graph window, we have this area here on the left where we can create variables. And we have 5 types of variables in the Unity Visual Scripting. So we have graph variables, object, scene, app, and saved. So first of all, let's see what's the difference between all these types. The graph variables are variables, and we have this description here. So basically, graph variables are variables that are only accessible to on the graph where they are created. So if I create a graph variable here on the game manager graph, only the game manager has access to these variables. When I say have access, it means that it is only the game manager graph that can access and change the values of these variables. So no other graph in the project can access it. Then we have the object variables. Object variables, as it says here, are variables that are shared across the current game object, which means that one game object might have one or more graphs associated with it. So when we use an object variable, it means that all graphs that are connected to this game object can access and change that variable. Then we have scene variables, and scene variables are variables that are shared across the current scene, which means that all graphs, whatever the object they are applied, all graphs can access this variable. Even if I create, actually, I have here the Visual Scripting scene variable. So even if I come here and I create a new variable, let's say, variable name, sorry, I need to input this first. So I create a variable called test as a scene variable. I come here to Visual Scripting scene variable, and you can see that I have the test here. And if I come to the crosshair now, and I go to the scene variable, I have this the test also here, which means that I can access this variable from the crosshair all graphs in my scene can access these variables. But for example, if I come here and I say this is a graph variable, I don't know, it's just for testing. And I add it here, then I come to the crosshair and I go to the graphs and it's not available here. So only the game manager can actually access this variable. I'm going to delete these variables. Then we have the app variable, and the app variables are variables that are shared across scenes. So let's say, for example, that we have like a common structure, like 3 scenes in our game. So a first scene where you ask the player for his name, then we have a scene with the actual game, and then we have a last scene with a high scores table. Let's say for the username, for example, this should be an app variable because we ask for the player name in the initial scene. Then on the game scene, we want to access that variable to show the username here on the game scene, and then we also want to use that variable and access that variable on the last scene with the high scores. So this should be an app variable because the variable needs to be shared across all scenes. So I need to get, and when I say share, I mean that I need to get access to that variable across different scenes. And then we have the saved variables. Saved variables are variables that persist throughout gameplay sessions. So when I say they persist, when I say gameplay sessions, it means that every time I play the game, I start the game and I stop the game, this is a gameplay session. So if I want a variable to persist throughout these sessions, and I need to create a saved variable. Let's say, for example, once again with the example with the high score, probably if I have something like that, I want to save the high score, so next time the game is played, I have the latest high score that someone achieved. That should be a save variable in a way that when I stop the game and start the game again, that value is saved. All the other variables that we are talking besides the save variable only exist on a single gameplay session, which means that when we stop the game and we start the game again, all those variables go back to their default values. So if I want a variable to persist, I need to create a saved variable. We are not going to deal with saved variables in these videos, in this game that we are creating, but probably I can make some other examples later with some other videos. So we have all these 5 types of variables, and I'm on the game manager, right? Yeah, fine. Okay, so let's see. We need 3 variables for our game. 1 variable for the ammo, 1 variable for the time, and 1 variable for the score. And one rule of thumb that it's really important to follow when you are coding is that you need to keep everything private by default. What do I mean to keep things private by default? Which means that this means that you should give an access level to your variables the most private possible. So in a way, when we are seeing this, when I say private, it means that less entities have access to that variable. Okay, so let's see how this applies to Unity, to visual scripting. A graph variable is the most private possible. And when I say private, why it's the most private possible? Because only the graph that created that variable has access to it. When I say that a variable is public, which means that not only the graph that created has access to it, but also other graphs can access that variable. So when I have an object variable, this is more public than the graph one, because not only the graph that created the variable, but also other graphs in the game object can also access it. When I say that I have a scene variable, this is even more public, because not only the graph in that object, but also other graphs in other objects can access the variable. An app is even more public, and the save is somewhat different, so doesn't enter this that we are talking about. So let's say that we have like continuum from private to public, from the graphs to the app variables, being the graph the most private ones and the app the most public ones. And by default, and this is for not only visual scripting but for coding in general, you should start with by default you should start the most private possible, because, and this rule is really important, because if you have a variable that everyone can access, let's say that I create all my variables as app variables, I could do that. I mean, it works the same way as using graph variables or any other way. But the problem here is that if I have a problem with that variable, when I say a problem, I mean that variable has a wrong value throughout the game execution. It's really hard to track what's happening because everyone in the entire app has access to that variable. So everyone can change that variable. And if I'm having a problem, if I'm having a problem with the variable, I'm going to have a really hard time figuring out, okay, who is changing the variable? I need to go all over my game, all over the scenes, all over all the game objects, all the graphs, and see, okay, who is changing this variable? But if I keep that variable private, if I keep my variable only as a graph variable, I know that if I have a problem with that variable, then it should be somewhere around this specific graph that is changing the variable because no one else has access to it. So this is a really important concept in programming. Of course, this has other names and everything, but basically my main takeaway with this is that everything is private by default, and you only increase the level of access. So you only increase the public level of access when you need to, if you only need to. And if you start making a lot of stuff as public, so if you start saying, okay, all my variables are becoming public, probably there is a problem with your entire architecture of your program, because if you start having everything as a public, probably the architecture is not the app or the game was not designed correctly. But this is more advanced than what we are doing right now. Just for visual scripting, for Unity visual scripting, just remember, okay, start most private possible. So start usually, okay, you think, okay, probably I'm going to use only graph variables, and only when you need to, you're going to say, okay, maybe I need an object variable for this because not only this graph is going to need to access it, or maybe I need a scene variable, or maybe I need an app variable. But make these considerations and really think about, okay, do I really need to have this level of access for my variables? Okay, so in this case, let's start with graph variable. Like I say, we're going to start with private by default, and then if we need, we change the variable and create, okay, maybe this cannot be a graph variable, it can be an object one, and we need to change it later. I don't know if it's really easy to change from one type to the other. I think probably we need to just delete and create another one, which might get problems if we are already at some other further point in our implementation. But either way, in this case, for the game manager, for these three variables that we are talking about, the AMO, the time, and the score, we are going to use graph variables. At least the AMO, it's only dealt within the game manager. The time is only dealt within the game manager. The only one that could be somewhere somewhat different would be the score, because we are actually, if we come to scratch, we are actually increasing the score when we destroy the target. So you can see that change score by 100, change score by 100. So all these sprites have access to the score. But I think in Unity we will try to implement a little bit different, because I don't want to have targets accessing the score and stuff like that. Only the game manager have access, and when these guys are destroyed, we are going to tell the game manager, okay, I was destroyed, so now increase the score by something. But we'll get there. Okay, so let's start and create variable. So we need a variable for the AMO. And here, in Scratch, you don't need to define the actual type of your variable. But in Unity, we need to do this, because Scratch only uses is like a generic type. So it's everything for Scratch is like a number. You can save numbers and strings. You don't have any other type of variables. Here you have different types. So you have floats for decimal numbers. We have integers for sorry, not decimal. Whole numbers. Sorry. You have integers for whole numbers, you have strings for texts, booleans for true and false values. Then you have some other that I'm not going to get into it right now. So for the AMO is basically a whole number, so we need an integer variable, and we can set our initial value of 100. Then we have another variable for the time. The time variable is also an integer number, because we are going to reduce the time by 1, so we don't need to deal with decimal points. There's no need here. and the value is going to start at 60, so we have like 1 minute. Variable name. We always need to start with the variable name. And then we have the score, and the score is also an integer and starts at 0. So this is how you define values with variables with the initial values. Comparing with Scratch, in Scratch you need to do this in 2 different steps. You need to create the variable first, and then you need somewhere in the game to set the initial value and always reset the initial value when we restart the game. In Unity we don't need to do this. In Unity you just create the variable, you say what's the initial value, and that's it. Let's just check here something about the... Yeah, everything is an integer. Yeah, that's correct. Okay, so we have this. Now let's deal with changing the AMO. So in Scratch, let's see. Okay, when I start game, we are not going to deal with this right now. So basically what we are going to do is to implement this loop. So while the game is running, if the user presses the mouse down, then I change the AMO by -1. Let's see how we can implement this in Unity. Okay, so first, we already know how to implement a loop, like a forever loop. For that, we use the update event. On update, we know that the onUpdate runs in a loop while the game is running and while the game object and the graph are active. So on update, now we have the if forever if mouse button down. And like I showed you before, we have these 2 nodes that we are going to use. So we have the if node, which is related to this if block, and we have the input get mouse button down, which is related to the mouse down. Okay, so we need an if block, and basically when the loop starts, it goes to the if block. And now in the if block, how does it work? So basically the if is a control block, a selection state, a selection node, which basically says, okay, if the value that we input here is true, then it's going to continue the execution on the top port. If the value that we input here is false, then it's going to continue the execution on the bottom one. So basically what we want is that the value that we want to get is if the user is pressing the mouse button. And we saw that we have a node for that, so input get mouse button down. You can see that we have several inputs here. So get mouse present. Okay. Easy text. Okay, we don't need to worry about this. So we have basically these 3 inputs. So get mouse button up and down. Up when it is true. So get mouse button up is true when the user releases the mouse button. Down is when the user presses the mouse button, and mouse button get mouse button is true while the user is holding the mouse button. So basically in this case we are going to use get mouse button down. So we are constantly checking, basically the update is constantly checking in a loop if the user is pressing the mouse button. And when the user presses the mouse button down, then this if block, this value becomes true, and this if block is going to continue here on the top port. And here, let's just check this node get mouse button down. We basically can define what is the button that we want, being 0 is the left mouse button. If I'm not mistaken, 1 should be the right one, and 2 should be the middle one. But so here it's okay, it's button 0. And so when the user presses the mouse button, it becomes true, and we come here. And here we are going to change the value of the AMO variable. So basically we are going to implement this change AMO by -1. Like I told you before, we don't have an actual node to change variable by a number. So what we need to do the actual operation. So we need to get the value that's in the variable, in this case subtract by 1, and set the value again. So basically in the end what we'll end up doing is setting the value of the variable. And you can see that when we set variable, we have like set graph, scene, all the sets for the different type of variables. In this case, it's a graph variable. Also, you can change that here when you are to use some different kind of variable. In this case, it's a graph one. You can open this, you can write This is something that really bothers me because in code this can lead to a lot of mistakes because you are just typing, and if you make a typo, then the code won't work because it just made a typo, so you are not accessing the correct variable and stuff like that. But here it's really cool because we have this drop down that automatically gives us the available graph variables that we have. So in this case, we are setting the AMO. And so the set variable, how it works. So it starts here. This is to continue the execution. Here we can input the name of the variable. You could give some input, but we can just change it from here. And here is the actual value that we want to input the variable. And the actual value, so we are changing the variable value by -1. So basically what we need to do is I'm not going to connect. We need to get the graph variable. So we need to get the value that's inside the graph variable, and we need to subtract this value by -1. By -1, no, by 1, sorry. So we get the variable. We input the variable to the subtract node. So, okay, take this value that's in this case, which would be 100. Take 100, go into the subtract, and here we need an integer literal. Basically, an integer literal is like the number, the whole number where you can define. So, and then we assign this here. Oh, sorry, graph. Okay, let me just explain this flow that I've created here. So basically what we are doing is that when we are constantly checking on update, on the loop, when the player presses the mouse button down, we are setting the variable, the AMO variable. And we are setting the variable with a new value that we are inputting here. And that new value is what? Is equal to the number that we have in the variable, the value that we have in the variable, -1, and we are setting that value. So we get 100, we input here in the subtract node, and the subtract node takes two inputs, one value and another value. So we are giving, okay, 101, and this node basically subtracts a minus b. So 100 minus 1, 99, and we are setting that value to the variable. Next time we press the mouse button, the value should be 99 minus 1, 98, and we set that value and we update the value. So basically this whole thing here is corresponds to the change my variable by 1, in this case by -1. And this is it, basically, to change the variable value. So let's see if this is working. I think we can see, I'm not sure, but I think we can see here the value. Okay, we cannot access here, but let's see if we can have the preview of the value here. So we start the game. Okay, you can see that the game is running on update, so it's constantly running. And this is false because we are not pressing the get mouse button down. So it doesn't continue, it stuck here. But as soon as I press the mouse button down on the scene, you saw that everything just run one time, and now the value is 98. If I press again, it runs again, 98, 97, 96, and so forth. And so I'm changing the AMO. Okay, so this was the first part, changing the AMO every time the player presses the mouse button. Now let's see the other one. The other one that we wanted to implement was to change time while the game is running. And this is a forever block. Again, we wait 1 second and we change time by -1. We already know that we cannot do something like this, so we have to do the whole operation that we actually want to perform. In this case, decrease the variable value. And let's see how we can wait for 1 second, because we don't have exactly this. We have something similar in Unity, but we are going to do it in another way. So if we have a forever block, let's create another on update. We could do this also on the same update, but because we have if conditions and everything, I think it's better to just create different updates. Just follow the same logic we use in Scratch. We can use different forever blocks. Here we can use different on update nodes. So on update, what we are going to do is to decrease the variable, the time variable. So set variable, set ref variable. Here we are going to be updating the time. Now let's see how we can update the time. And basically, we could just decrease, just like we are doing here. Let's just copy this and paste. Here is not the score, but the time. And we could just do something like this. And this is going to be running on a loop. Now, but we have a problem with this. I'm just making this and I'm going to show you because this won't work, and let's see why. So basically, on every loop, we are subtracting 1 from the time variable and updating the value. Let's see what happens here in the time. You see the time is actually decreasing, but it's decreasing a lot. You see that it's already at minus 2000 and something, but it's working. Now, what happens is that we are not actually decreasing because we want to decrease 1 second from the time. Every time 1 second passes, we want to decrease 1 from the time variable. Now, the problem is that the onUpdate does not run on seconds, but it runs by frames. So if basically what we are doing is that we are decreasing 1 from the time variable on each frame. And if we go back to our game and press play, let's just see how much frames we are running per second. If we enable here the stats, you can see that our game is running at 300, 400 frames per second, which means that we are decreasing the time by 400, 300, 400 times per second. That's why we have this number here. Okay, so what we need to do here is that we cannot be decreasing the time variable by frame, but instead by second. So we need to use another block, which is called the time delta time. Get delta time, actually. And basically, the delta time is the time that each frame takes. So when we multiply any value by time delta time, time delta time is from code. When we multiply a value by get delta time, we are basically converting that value to, instead of being by frame, we are using that value by second. Basically, this is what you need to understand. If you want to do something by seconds instead of doing by frame, you need to multiply that value by time delta time. So instead of subtracting 1, we need to add another block here, which is a multiply block. And now we input this one here, and we input this one here, and then we subtract the result of this multiplication. So when we want to do something by seconds and not by frame, we need to multiply the value by get delta time. And remember that delta time is the time that the last frame took to complete. So when we multiply it by it, we are basically not converting, it's not exactly converting, but we are adjusting that value to run by seconds and not by frames. So the interval in seconds from the last frame to the current one. Okay. And now let's just see if we run the game. You'll see that this value is going to decrease by second. So now you can see 55, 54, so you can see that time here, so this is 1, time delta time, I don't know why it's 0, it should be a 0 point something, because basically it's the time of the last frame, so if you have like 400 frames per second, it should be like a really small number. And we are multiplying here, and we are changing the value. And actually you can see that this is really cool from Unity Visual Scripting, because I define we declare the variable as an integer, but since it's multiplying by a decimal number and everything, and we are subtracting from time, it just changes the variable to a float, because the variable is actually a float. It's a decimal number, but we are going to use it as an integer, at least to show it on screen, but it automatically converts the variable to a float because it is assigning a float variable into the variable, which is pretty cool. And yeah, so this is it about variables and about changing variables. So main takeaways. remember that when you are creating variables, remember to think about the type of access that you want to give to your variables, and always start, and at least try to always have the most private variables possible, which means that the graph variables are the private ones, and the level of access increases with this type when you are moving to the right. And the other takeaway is that when you want to change a variable, you don't have a block to actually change variable by something. You need to perform the operation to update the variable value. And then when you want to do something by seconds, when you want to change a variable by second or use a value by second, you always need to multiply the value that you want by delta time when you are running on an update loop. And so yeah, this is it about variables. And in the next video, we'll see how we can communicate to start implementing the actual logic of the game, so having the label ready and everything. So we'll need to see how we can communicate between different graphs. So this is it. Thank you, guys.